Okay, after that, we would go into the next section. That would be the different expressions of mechanical energy. So previously, we have derived the work done by pressure, that's the flow work. And then we would also include this term into the mechanical energy. Okay, so the mechanical energy for flowing fluid per unit mass will be this term. Okay, E mechan equal to P divided by rho plus V squared divided by 2 plus G times Ez. Okay, so these two terms will be the Ke per unit mass, and this one is a Pe per unit mass, and this one is a flow work. Okay, okay, we need to include this term for flowing fluid. Okay, for flowing fluid only. Okay, if the fluid is non-flowing, for example in a closed system, then this term should not be included. Okay, I will explain it in more detail at chapter 4. Okay, and here we also have the race form. Race form would be E mechan dot. Okay, as I mentioned, dot would be the time rates of change, equal to m dot times E mechan. So we will have this expression. You just plug in what we have said in the previous slide, and that's okay. Well, during an incompressible flow, that means if the density is constant, then the mechanical energy change per unit mass will be given by delta E mechan. Because the rho is constant in this case, so we just have P2 minus P1 divided by rho. Okay, and plus the change in Ke, so V2 squared minus V1 squared divided by 2. Let me write that down. So here, this term would be the delta W flow, and this one is the delta Ke, and this one is a delta Pe. Okay. After that, we will also have the rate of mechanical energy change of a fluid during incompressible flow. You just multiply both sides by m dot, and that's the expression. And here you can see that because it's mechanical energy per unit mass, so we will have kilojoule per kg in this case. But that's not the default unit. The default unit should be joule per kg. So once you calculated all the values in terms of SI units, you need to divide it by 1000 to obtain kilojoule per kg. Similarly, if you plug in all the correct SI unit to calculate this expression, you should get the units watts. Okay, watts. Then in order to change it to kilowatts, you just divide this term by 1000 and you can get the solution.